Hey guys, today we're going to talk about something called heat. Hope you're excited for it. I'm super excited for it. Before we start though, one of the things I wanted to talk about is why does hot air rise? Go ahead and think about that for a minute. Why do you think hot air rises? Okay, here's what I got for you. This right here in blue is cold air. Notice that it's at the bottom. Here we have some warm air in orange, and notice how it's higher up. What do you notice about these two things here? Hopefully you notice that they're both kind of taking up the same amount of space, but the air in orange here, there's significantly fewer air particles in this space. So what we would say then is that not only does it rise, but it rises because it's less dense. There's less mass in the same amount of volume. Remember, density is mass divided by volume. So since our mass is low and our volumes are the same here, we would say that this all has to do with density. Now, one of the things you might be wondering is, why does temperature do this? Why does specifically temperature change what's dense and what's not dense? And that's what we're going to talk about today. We're going to talk a whole bunch about temperature, heat, and this other thing called thermal energy. Let's start with heat, for example. We're not going to get that far quite yet. Okay, so a couple things happen when an object gets warmer. The first thing we're going to talk about is we're going to talk about the particles. That's these guys right here. So you can think of these as kind of like mock-ups of atoms. And then we're going to talk about the object itself. So actually like a little sample of air. Hopefully particles versus object, that makes sense. Okay, so when an object gets warmer, here's what happens to the particles. Thing number one is particles move faster. That's exactly what heat is, what temperature is. Temperature is a measurement of particle speed. So that's something that you might not have known before, because temperature is pretty obscure, right? It's just how cold it is. So it's kind of like it's the same. I don't know. It's difficult to understand, but we as scientists found out actually that temperature is directly related to atoms' speeds. So the faster atoms moves, the higher temperatures they have. Kind of cool. Now, if atoms are moving faster, what that then means is there's also more space. So here it says particles move further away from each other. As they move faster, there's more gaps in space. And that's what we see if we flip back over here. We see that there's huge pockets of space in between these little air particles, versus in the colder air, less space because they're moving slower. Kind of cool. Okay, what does this mean about the actual object? Well, hopefully you saw that as we warm things up, they become less dense. So remember, if you have the same amount of stuff, but as you heat something up, it expands. So you have the same amount of stuff taking up more volume. That means mass divided by bigger volume means it's less dense. So as objects get warmer, they get less dense. Hot air rises, right? Or as objects get colder, they kind of shrink down a little bit and they become more dense. So that's one thing. Objects become less dense. Number two, we can also say that an object has more energy. So as you, for example, heat up a solid, eventually it might turn into a higher energy liquid, for example. Or as you heat up a liquid, it might turn into a higher energy gas. When it goes from a solid to a liquid to a gas, it's going to take up more space, which is something we know from last unit talking about phase changes, right? We know that solids have little energy, liquids have more energy, and gases have the most energy. And also solids are the most dense, liquids are in the middle, and gases are the least dense. Okay, these are the three terms you're going to need to know. These are kind of what quiz questions will be on. This is what daily assignment questions will be on for today. Let's start here with heat. Heat is known as the transfer of energy from one object to another. So heat does not actually measure the energy, it measures a transfer of energy. Think about it like this. If you're heating up your hands, you're not talking about what the temperature of your hand is, you're talking about the change in temperature of your hands. And if you're heating up your hands, you're getting that energy from another source. Maybe it's a fire, maybe it's a fan, or I don't know, like a heater, something that blows heat on your hands. Temperature. Let's move on to that. Temperature is going to be, we have to be very, very specific here. So temperature is, according to scientists, it's the speed or the average kinetic energy of a particle in an object. So what that means, that's pretty scientific, right? It's talking about kinetic energy is the same thing as speed. So here I wrote it down as the average speed of a particle in an object. That might be a little bit easier to write down. Also know that speed equals kinetic energy. Make sure to write that down. Also write down the definition for thermal energy when we get to it, and write down the definition for heat. Okay. What this means here is temperature. When you stick a temperature probe in an object, what you're really doing is you're figuring out what is the average speed of those particles. So temperature, you can kind of think as one particle specifically, how fast is it moving? And that particle is kind of the average for all the particles. Thermal energy is a little bit different, but it's very similar to temperature. So instead of just measuring what the speed of one particle is or figuring out what the average speed of each particle is, thermal energy says, okay, I'm measuring the speed of a particle or the kinetic energy of a particle, same thing, and I'm thinking how many particles total do I have? So thermal energy is the total amount of kinetic energy in an object. What this means then is that for temperature, it doesn't change if you have, let's just say you have like a gallon of boiling water, or maybe you have 10 gallons of boiling water. The temperature would be the same for both of those. If you have a gallon of thermal energy, that has a lower thermal energy than 10 gallons because you've got more water that's still boiling. And it would also take more energy to keep it boiling or to keep heating it up. So you can also think of it, remember, kinetic energy, kinetic means movement. So instead of thinking about the average kinetic energy of an object, you're thinking about the average movement of particles in that object. So those are the three terms you're going to need to know, and we're going to look to apply those with some questions. So coming up now, we have some questions just to kind of test your understanding and also hopefully clarify any misunderstandings you might have about heat, temperature, and thermal energy. Here we go. Before we leave, make sure you write down these definitions. They're important. They're going to come up early and often. Okay, so heat is a form of kinetic energy. It's not matter. It's measurable. It's a transfer of energy between objects. That's the key here, transfer. Hopefully you have this written down. You don't have to write this all down, but you should have transfer of energy somewhere in your notes. Make sure you have that. Temperature, it measures how fast particles are moving. Remember, it's the average thermal energy. So I wrote down energy per particle. Maybe that's a good way to kind of summarize what we've written so far. Energy per particle, or you could also think of it as speed per particle. So look at an individual atom, look at an individual particle. How fast is that particle moving? How much energy then does it have? So one of the things I hope you notice is that energy is the same thing as speed here. Energy can be expressed in a lot of different ways. In this case with heat, we really just look at speed. Cool. Okay, last one is thermal energy. Thermal energy, remember we said it's the total amount of kinetic energy in an object. You should have that written down. So it's going to measure two things. It's going to look at mass, and it's also going to look at temperature. Or it could look at volume, which then you could find mass, and it's looking at temperature. But those two things are both equally important when it comes to thermal energy, mass and temperature. So it's not just that the water has a temperature of 20 degrees Celsius. It's also you have 100 grams of water. Both of those are important when it comes to measuring things with thermal energy. Okay, next thing we're going to talk about is called the law of conservation of energy. And what I've heard people say before is that in winter, your head heat, never mind. The law of conservation of energy, ignore that thing in blue, says energy cannot be created, nor can it be destroyed. Now, remember, we know heat, temperature, and thermal energy, they're all types of energy. So you can't destroy heat, you can't create temperature, you can't destroy thermal energy. Instead, what you do is you transfer energy. And that's where heat comes in, right? Heat is the transfer of energy. So it's not like when it gets colder, the warm just goes away. It gets transferred somewhere else, or it gets lost. Oftentimes people will say your head loses heat in the winter. That's not really true. Your head is actually heating that cold air around you. So energy is never lost. It's never found. It's not created. It's not destroyed. It's transferred. That's the key here. So energy just moves from one matter to the other. And we call that transfer of energy heat. Cool. Okay, so here we've got two substances. We'll say that this substance 1, we're just looking at, I don't know how many particles that is, 12. And then over at substance 2, it's got 4 particles. So right away we notice this has more mass. Substance 2 has less mass. And the question is, which has a higher temperature? So I'm going to show you, I'm going to play the animation. Here's substance 1 moving, kind of jiggling around. And there's substance 2. So looking at the two of them, which would you say has a higher temperature? Hopefully you picked substance number 2, because if you look, it's moving faster. Remember, temperature is based on the speed of particles. Hopefully you have that written down in your notes. Next thing I want to look at is same picture, but now the question is, which one has a higher thermal energy? And this one is close, but I bet that it's probably substance 1, because there's just more particles here. So even though it's moving at a bit of a slower speed, the number of particles we have is so much greater that the total combination of number of particles and speed beats out just the really fast 4 particles here. So we would say that thermal energy, remember, is based on both speed and mass. That's the key there. Last question I have, which one of these two has more heat? Kind of a trick question. Hopefully you said neither, right? Because heat is the transfer of energy, right? So heat is not, you can't just look at something and say, ooh, that has more heat. That's not the phrase we would use. Instead, we would use temperature. But here's a question we can answer, right? Heat is the transfer of energy. So assuming these two things collided, which way would heat move? Which one would get warmer? Substance 1 or substance 2? Heat, we know, always moves from things that are hot to cold. So since substance 2 has a higher temperature, these particles would collide with substance 1, and the average speed of all the particles would increase. So we would say that heat always moves from hot to cold. That's maybe something that you knew, but it's definitely worth writing down in your notes, just because it's going to come up a lot as we move forward here. One of the things you can think of this as is you can think of substance 1 as kind of like 1,000 milliliters of cold water, and you can think of substance 2 as like 10 milliliters of warm water. So if you take those 10 milliliters of warm water and you pour them in, it's going to heat up everything just a little bit, or it'll make it less cold at the very least. Energy increases overall. Hopefully this makes sense, this little picture here. What I want to do is do more problems now. Instead of showing you pictures, we're going to show you words instead, and we'll have you do very similar things. Compare temperatures, compare thermal energies, and also kind of compare which way heat would move. Hopefully you're ready. Here we go. Okay, so the question is, which has more thermal energy? And we've got 100 milliliters of water versus 100 milliliters of water at 4.5 degrees Celsius. So here, two different temperatures. Which one has more thermal energy? We would say not that one. We would definitely say the one on the top. LOL. Let me just change that real quick. Yeah, the one on the top has more thermal energy because it's at 99 degrees Celsius and the amount is the same. Okay, same question, a little bit different. Now we're looking at 100 milliliters of water or Lake Superior. Which one has more thermal energy? It's definitely going to be Lake Superior. Lake Superior is a lot bigger. So like a lot bigger. So way more thermal energy. Okay, next one. Lake Superior at 4.5 degrees Celsius or a swimming pool at 27 degrees Celsius. That's like a balmy 80 degrees, in case you're wondering. 4.5 degrees Celsius is like 40, so it's very, very cold. Superior is very, very cold, especially this time of year. I would still say not a swimming pool. Mr. Smith, what are you doing? I would still say Lake Superior is probably the more thermal energy just because it's so big. It's huge. Okay, so 3 measurement scales. We're going to talk about that tomorrow. Thank you guys for listening. Thank you guys for taking notes on heat. I hope you have a great rest of your day. We'll see you later. Bye-bye.